All right. If you write code, you definitely know the feeling. A project kicks off, it's all clean and organized, and then, bit by bit, it just descends into chaos. But what if I told you there are secret blueprints that the pros use to avoid that exact problem? Well, today, we're cracking open that toolbox and looking at one of the most powerful concepts for any developer: software design patterns.
I mean, we've all been there, right? You start a project and everything makes sense. But as it gets bigger, you add more features, and before you know it, you're staring at this giant, tangled web of code. It's a nightmare to debug, a pain to manage, and forget about trying to explain it to a new person on the team.
And here's a classic symptom of that mess. You realize you're solving the same kinds of problems again and again. You're creating an object here, handling a user click there, but you're doing it in a slightly different way every single time. Yeah, it works, for now, but it's inefficient and it creates a really brittle system that can break easily.
Well, here's the good news. You don't have to constantly reinvent the wheel. For so many of these common challenges, there are already expert-level, time-tested solutions just waiting for you. Think of them like proven recipes from the world's best chefs. And that, my friends, is exactly what a design pattern is. Now, this is super important. They're not finished code that you just copy and paste. No, think of them as blueprints. They give you the template, the structure, the idea for how to solve a problem in a way that's clean, maintainable, and built to last.
To make sense of it all, these patterns are usually grouped into three main categories. You've got creational patterns, which are all about how objects get made. Then there are structural patterns, which help you build objects into bigger, more complex structures. And finally, behavioral patterns, which manage how all these different objects talk to each other. Knowing this is like having a map of the toolkit, and it gives you a shared language to talk about design with other developers. Okay, enough theory. Let's make this practical. Imagine you're building a simple drawing app. The user can click a button to draw a circle, or a square, or maybe a triangle. Your code has to create the right shape object on the fly, but you have no idea which one the user is going to pick ahead of time. This is the perfect job for the factory pattern. It's a creational pattern that basically sets up a central hub for making objects. So instead of having bits of creation logic scattered all over your code, you hand that job over to a single factory. Your main code just walks up and says, "Hey factory, I need a circle," and the factory figures out how to make it happen. And here's what that looks like in practice. You have a shape factory class, and its only job is to take a request, like the word circle, and hand back the correct object. The magic word here is decoupling. Your main application doesn't need to know the messy details of how a circle object is actually built. It just trusts the factory to do its job. This makes your code so much cleaner. Okay, let's try another one. This is a classic. You're building an e-commerce site. You need to let people pay with a credit card, or PayPal, or maybe a gift card. So how do you handle all those different payment methods without writing a giant, horrifying if-else block? You know the one I'm talking about. Well, this is where the strategy pattern comes in to save the day. It's a behavioral pattern, and it's brilliant. It lets you define a whole family of algorithms, in our case, our payment methods, and you wrap each one up in its own separate class. The result? They become totally interchangeable, like little Lego bricks of logic. So the way this works is you start with a kind of contract, this payment strategy interface. Then each payment method, your credit card logic, your PayPal logic, gets its own class, and they both promise to follow that contract. Now here's the best part. Your main checkout code doesn't care which one it's using. It just knows it has a payment strategy. That means next year, when you want to add Apple Pay, you just build a new class. You never have to touch your core checkout logic. How cool is that? So at this point, you might be thinking, okay, this is neat, but is this just academic stuff for textbooks, or do people actually use this in the real world? And the answer is a huge, resounding yes. It's literally everywhere. Just look under the hood of any major modern framework. Take ASP.NET Core, for example. That whole powerful dependency injection system, it's built on patterns like strategy and factory. The logging service you use all the time, that's the Singleton pattern. The filters, that's the Decorator pattern. This stuff isn't academic. It's the very foundation that robust professional software is built on. So why does all this matter? What's the big takeaway? It all comes down to this. Using design patterns helps you write code that is fundamentally better. It's modular, which means your code is like a set of well-organized toolboxes instead of one giant junk drawer. It's testable, because you can easily check each tool on its own. And most importantly, it's scalable, which is the holy grail, right? It means your application can grow without collapsing into that tangled mess we talked about at the very beginning.
So, the next time you sit down to write some code, just pause for a second. Instead of jumping straight to the solution, ask yourself, is this a common problem? Is there a blueprint for this? Because using these patterns isn't just about becoming a better coder, it's about starting to think like a software architect. So the real question is, which pattern will you spot or use in your next project?